In this video, we're going to use calculus to show that the area of a circle is indeed pi r squared. Now, you've seen this in high school, but you never really understood why it is. So let's use calculus to show this. So start out with the equation of a circle, which is given by this, and the idea here is that we're going to integrate it from 0 to r, and we're moving in the x direction. We're summing up all the heights, and then we're moving in the x direction. So it's going to be something dx, and we're summing up all the heights. Well, the height is given by us rearranging this to make y the subject. So take away x squared from both sides. That will then be this thing here, y squared, and then square root both sides. So y equals square root r squared minus x squared plus minus. Now the positive square root will then give us this thing here. The negative square root will give us this thing here. We're not interested in the negative side, so let's just concentrate on the positive side. So let's start again. We're summing up all the heights, and we're moving in the x direction. So it's going to be from 0 to r, all the heights in the x direction. Well, the height is given by square root r squared minus x squared, and then this thing here will then give us the area of a quarter of a circle. But if we want the whole area, it would be four times this thing here. So now it really boils down to us evaluating this thing here. So the whole area of the circle is given by this thing here. So the whole area of the circle is given by this thing here. So now to integrate this, if you have an x here, then this whole thing here will be easy to integrate, because this x here is the exact derivative of this thing here. So it's easy to integrate. But because we don't have an x here, it becomes a lot harder to integrate. Bear in mind that r is a constant, because the minute r in our case is a constant, because the minute I ask you to work out an area of a circle of radius 7, the minute I give you the radius of 7, then this 7 here stays fixed. So even though you're integrating it with respect to x, you see it is the x that's moving about. This r here stays fixed as a radius of 7. So the minute I set the problem of radius 7, then the r is a constant. So going back to this, bear in mind that r is a constant. And bear in mind that because you don't have an x here, if you have an x here, it will be this thing here will be the exact derivative of this, which would be easy to integrate. But because we don't have an r here, it becomes a lot harder to integrate. So to integrate this, your eye should zoom into this bit here. Create a triangle, a right angle triangle, in such a way that this thing will be true. Well, if you make the hypotenuse to be r and the opposite to be x, then the adjacent, let's call this theta, the adjacent will have no choice but to be r squared minus x squared and then square root. It's really us using Pythagoras. If the hypotenuse is r and this is x, then the adjacent will have no choice but to be this thing here. So now, so to integrate this, you create a triangle in such a way that this thing here will be true. So create this triangle, make this r, make this x, then the adjacent will have no choice but to be this. But then if you look at this, we need to replace this dx. So to obtain that dx, if you look at this triangle, sine the angle equals opposite over hypotenuse. So times both sides by r, that will then give us this, and then now you can differentiate. Differentiate this will give you dx. Differentiate this will be r cos theta, d theta. So now, so that will then give us this thing here. Okay, so now we can put this into the dx, and then looking at this complicated thing. Well, if you look at this, cos theta equals this complicated thing, square root complicated thing, over r times both sides by r. That will then give us this thing here. So we can now put this into this complicated thing here. And then we can put this into this thing here. So that will then give us this thing here. Okay, so it really boils down to us integrating this whole thing here. But remember, here we are integrating with respect to x from 0 to r. So if you look at our circle, here we're doing it, we're summing up everything. We're moving along in the x direction from 0 to r. But here we've changed everything and we work in terms of theta. So we need to change these, because we need to integrate it in terms of theta rather than in terms of r. Because in terms of r, you're really doing this. You're summing up everything in terms of the dx. But then because you're working in terms of theta, we need to change these. I will continue in the next video. Okay.